Hello and welcome back to the third video on end-to-end machine learning project. In the last two videos, we were able to fetch the data, the zipped folders, and extract them to the TSV file and then perform the data pre-processing to that to get our final data frame. And then we performed some data analysis on that to answer some of the questions in the last video. And after applying everything, this is the final data frame that we had with us. So this data frame basically contains 252,307 rows, which is a lot of rows. And there are a lot of features as well that we are using. So I would like to mention that the similarity matrix, the cosine similarity matrix that you can compute, basically if you compute for such a huge data set, it is going to require a lot of computation power, and we don't have that kind of RAM right now to store everything. So what I'm going to do in this is I would just reduce our data frame to contain the movies which were released in 2020 and after that, so that we don't have a lot of data frame lot of data in our for our analysis. But I would like, if you guys want to build a content-based recommendation system model, then I would definitely suggest you guys to check out this GitHub file that I have created, so collab file which I have shared here on the GitHub. So this thing actually contains the link to the YouTube video as well, where I explain how I created this, and this is using MovieLens 25 million data. So it contains 62,422 movies which I have used, along with the tags, which genome tag file which is available in MovieLens data. So using this, I create a content-based recommendation model which performs really well and gives me pretty good results. So you can check that out, and you can and I can tell you that if you're using a collab with TPU and you have 35 GB of RAM, then you will be able to perform that task easily. I mean, not easily, that is going to consume around 34 GB of RAM, but you will be able to build that model and get that final data frame as an output. And this data frame, similarity data frame, when you just export this as a pickle file or as a CSV file, this would be around 1 GB file. So it's not a huge file, but it's fine. So you should definitely check out this video and this GitHub file, the collab file which I shared. So for now, what I'm going to do is I'm just going to apply this filter, and this will leave us with 20,871 movies. So we are going to use sklearn, and we'll use TF-IDF vectorizer from sklearn. And then to calculate the cosine similarity, we'll use again sklearn package. Next thing what we are going to do is we are going to create a new column in the data frame called content. Now this content column which will be created is going to use, so whatever features you want to use in this data frame to calculate the similarity score, then you should include all those features into this content column that we are creating. So I want to use the name of the movie, I want to use the runtime minute, I want to use genre, directors, writer, average rating, number of vote, actors, all these features to calculate the similarity between the movies. So I have added all those things to finally create this column called DF content, and then applied a little bit of pre-processing to this particular data frame. So my data frame is ready here. This is what my data frame would look like. So it would have a new column, content, and this content is going to contain all the information from the title to year when it was launched, what was the runtime, genre, etc., etc. Now using this, I am going to create the TF-IDF vectorizer. So I will define my TF-IDF vectorizer here. Then I would put DF content into the transform, and then I will create the cosine similarity matrix using that TF-IDF matrix that we create, and then finally we will create a similarity data frame. So this process might take a little bit of time because it's a huge data frame that we are creating, and you can see here the RAM consumption is going to go really high. Okay, that was quick, maybe because we reduced the data set. Now if I look at the similarity data frame, what does it look like? So we have 20,871 columns and 20,871 rows. So this is what it looks like. Now the next thing, so since we have our this thing created, the next thing would be basically to ask a user to input a name of the movie and then return the top 10 movies similar to that. So what I'm going to enter is basically Avatar from 2022, and the result it gives me is basically Mulan 2020, which was released April, which was released in 2021, Bollywood in 2020, Black Friday, and so on. This is the similarity score which it is giving me. So yeah, this is not the best recommendation system. I don't know how big this file is, the similarity data frame that has been created, but I think it is around 3 GB or 3.5 GB last time I checked when I exported this as a pickle file. So again, that is a lot, and that is probably because of the number of columns we have. So for the final file that you export as a pickle, I would suggest this you can do this as well, like if you have that kind of computation power, but I would suggest you follow this collab file to finally get this similarity data frame and export that as a pickle, because that is what we are going to use in the next video to build a Flask application, a Flask web application, movie recommendation web application. So I'll see you in the next video, and till then, happy learning.